So today we have a very interesting geometrical problem. We take a triangle A, B, C in which the angle C is 90 degree. Now we inscribe a circle inside this triangle such that it is tangent to all the three sides. Now we mark the center of the circle as the point O. Now we draw a line segment from the point A that passes through the point O and intersect the line segment BC at point Q. Now we draw another line segment from the point B that passes through the point O and intersect the line segment AC at point P. Now let the area of the triangle POA be equals to capital X and area of the triangle BOQ be equals to capital Y. Now the question is to get area of the circle in terms of X and Y. So this is Anmol Mishra, and now let us see the solution. How can we find area of the circle? So first of all, we will take the radius of the circle as a variable r. So now our goal is to get the value of r in terms of x and y so as to get the area of the circle in terms of x and y. So for that, we'll simply utilize the fact that the circle is tangent to all the three sides of the triangle. This means we can use that particular theorem that the angle formed at the intersection point of the radius and a tangent line is always 90 degree. Therefore, when we will draw radius to these three particular points, the angle formed over there would be 90 degree. Now let us label these three intersection points as D, E, F. Now as we have taken the radius of the circle as a variable r, therefore the length of the line segment OD, OF and OE is going to be equals to r. Okay, now carefully observe the diagram. On the base AC there are two perpendiculars. The angle D is also 90 degree and angle C is also 90 degree. Therefore the line segment DO is parallel to line segment CB. Now similarly take the base CB on which we have two perpendiculars. Angle F is also 90 degree and angle C is also 90 degree. Therefore the line segment FO is parallel to line segment CA. Okay, so now we have two pairs of parallel line. So first of all, we'll utilize the fact that OD is parallel to BC and the line segment BP is a straight line. Therefore, if I take the angle OBC as a variable theta, the angle POD is also going to be equals to theta. Now similarly, we have the second pair, that is OF parallel to AC. So if I take the angle OAC as a variable alpha, the angle QOF is also going to be equals to alpha, as the line AQ is a straight line. Okay, so here we have marked the important angles that we required in the solution. Now let us mark the important length. So let the length of the line segment AP be equals to a variable A and the length of the line segment BQ be equals to a variable B. Now let the length of the line segment PD be equals to M and length of the line segment QF be equals to a variable N. Okay, now we will try to derive a relation between theta and alpha, because excluding variable in any solution is the best way to reach the answer. So here we can see that the triangle OAD is congruent to triangle OAE because of right angle hypotenuse side. So once two triangles are congruent, rest of the things between them become equal. So the angle OAD equals to angle OAE and that is going to be equals to alpha. Now similarly, the triangle OBF is congruent to triangle OBE. Therefore the angle OBF equals to angle OBE and that is going to be equals to theta. Now take the complete triangle ABC. On applying the angle sum property in it, we get 2 times theta plus 2 times alpha plus the 90 degree equals to 180 degree. And when you will simplify this particular equation, you will get theta plus alpha equals to 45 degree. Okay, so here we have got the particular relation between theta and alpha, that is theta plus alpha equals to 45 degree. Okay, now let us start with the actual solution, and let me tell you that we are going to use trigonometry because everything over here is perfect right angle triangle and we are going to take 4 of them. The first right angle triangle is AOD, the other right angle triangle is FOQ, the third right angle triangle is BOF and the fourth right angle triangle is POD. Now in the triangle AOD, the value of tan alpha is going to be equals to R upon A plus M, and in the triangle FOQ, the value of tan alpha is going to be equals to N upon R. Now in the right angle triangle BOF, the value of tan theta is going to be equals to R upon N plus P. And now finally in the right angle triangle POD, the value of tan theta is going to be equals to M upon R. Now here we can see that we have two values for tan alpha and two values for tan theta. So now let us compare their right hand side. So we have the value of tan alpha as equals to n upon r and is also equals to r upon a plus m. Now after doing cross multiplication, we will get r square equals to an plus mn, and let it be equals to equation 1. Now similarly we have tan theta equals to m upon r equals to r upon b plus n, and when you will do cross multiplication, you will get r square as equals to bm plus mn. Now let this equation be labeled as equation 2. Okay, now we are going to use a trigonometric identity, that is tangent of addition of two angles. So here we take tan of theta plus alpha. So as per the identity, it is going to be equals to tan theta plus tan alpha divided by 1 minus tan theta tan alpha. Now as per this equation, we have that theta plus alpha equals to 45 degree and tan 45 degree has a value 1 equals to. Now look carefully over here, we have the value of tan theta as equals to m upon r plus, now we also have the value of tan alpha, look carefully over here. So tan alpha equals to n upon r divided by 1 minus m upon r into n upon r. And when you will simplify this particular equation, you will get r square minus mn equals to r multiplied with m plus n, and let this be equation number 3. So all the three equations that we just derived, I've kept them together. Now look carefully in the first equation and in the third equation. We can simply put the value of r square from the first equation in the third equation. So now the third equation will look like an plus mn minus mn equals to r multiplied with m plus n. Now we can simply cancel out mn, so we will have an divided by m plus n equals to r. So here we have got something nice equation. Now we are going to compare the first equation and the second equation, because the left hand side of both of this equation is same, that is equals to r square. So we can simply compare their right hand side. Therefore an plus mn equals to bm plus mn. Now from both of this side mn got cancelled out, so we finally have something like this: a upon b equals to m upon n. And from this particular equation we have the value of m as equals to an upon b. So here we have got the value of m, and we are going to put this value of m in this particular equation. So now we will get the final equation as r equals to ab upon a plus b, and this is the most important equation. Okay, so now we are just few steps away from the final answer. Now look carefully that the yellow triangle and purple triangle are obtuse triangle. Now in the yellow triangle we can clearly see that OD is height of this triangle and AP is base of this triangle. Therefore, area of the yellow triangle equals to capital X equals to half the base, that is equals to A, into the height, that is equals to R. Now from this particular equation, the value of A equals to 2 times X upon R. So here we have got the value of A. Now again look in this purple triangle. OF is height of this triangle and BQ is base of this triangle. Therefore, area of the purple triangle, that is equals to Y, equals to half the base, that is B, into the height, that is equals to R. Now from this particular equation, the value of b is going to be equals to 2 times y upon r. So here we have got the value of b. Okay, so here we have got the value of a and the value of b in terms of x, y and r. But what we are going to do with it? So remember the most important equation, that is r equals to ab upon a plus b. In this we are going to replace a and b with their new values. Okay, now let us put the values of a and b in the most important equation. Therefore, the most important equation is r equals to ab upon a plus b. So now r would be equals to the value of a, that is 2 times x upon r, multiplied with the value of b, that is 2 times y upon r, divided by a plus b. Therefore 2 times x upon r plus 2 times y upon r. Now when you will simplify this particular equation, you will get r square equals to 2xy divided by x plus y. Now we will simply multiply pi on both of the sides. Therefore pi r square, that is equals to area of the circle, because we have taken radius of the particular circle as equals to r, and this thing would be equals to pi times 2 times xy upon x plus y. Hence we have got area of the circle in terms of x and y, and that's the answer that we were looking for.